Hi guys, we are going to take a look at the first section of chapter 6. The front page, you can actually just do a lot of reading on your own, but I am going to point out some things. So we are going to talk about angles, not necessarily triangles per se, but just angles in general. So you've got an angle, it's formed by two rays with a common point called the vertex. We've got two sides. One is the initial side, which is where we're going to start measuring our angle from, and then we have a terminal side. So it starts at the initial, it ends at the terminal. When they measure angles, a lot of times they will use these Greek letters. I've kind of talked to you about that a little bit. This would be an alpha, that's a beta, that's a gamma. Theta, again, is the one you'll probably see more often than any others. So this is an example of an angle. It has counterclockwise rotation. That's how we measure most angles. We measure them counterclockwise, so the opposite the way that a clock would go. And that is a positive angle. So for example, that looks like it's maybe a 30-degree angle, if I just had to guess. Okay. Now the one next to it, exact same angle, but this one, if you look at this arrow right here, they're measuring it in the clockwise direction. And a clockwise rotation means that it's a negative angle. So if this is 30 degrees going this way, and this is almost all the way around like a complete circle, except for that 30 degrees, then this would be a negative 330 degree angle. Okay. The one next to it, this one, so again, if you kind of follow this arrow, it starts here, it goes all the way around a complete circle, and then keeps going about the same amount that our first one did. So this would be a complete circle, which is 360 degrees, plus that extra 30 degrees to open it up, so that would be a 390 degree angle. Okay, so positive, positive, and then that's a negative angle right there. When we are looking at angles, we are going to be looking at them on a coordinate plane where they're going to take the vertex of the angle, they're going to place it right at the origin. The initial side is going to run right along the positive x-axis. Okay, and then a lot of times we can show, and then the terminal side, so here's the terminal side of this one. Okay, and they are measuring this one, they're labeling it with a theta, and this would be a positive angle. And again, it's the way they're showing that arrow right there, that it's opening up in a counterclockwise manner. Okay, whereas this one over here, this one, they're opening it this way, so that would be a negative angle. Again, both of these are in what's called standard position, and whenever we draw our angles, we will always draw them in standard position. Vertex at the origin and initial side going along the positive x-axis. Okay. When an angle is in standard position, the terminal side will lie either in a quadrant, so you've got quadrants 1, 2, 3, and 4. So those are your quadrants. And if that's the case, we say that theta lies in that quadrant. So this is an example where we say that the angle is in quadrant 2. Okay, now I know that most of the angles in quadrant 1, and it just kind of ends in quadrant 2, but that's how we say that. Okay, so that angle is in quadrant 2. This angle is in quadrant 4, or lies in quadrant 4. This one that goes around and then lands on like the negative y-axis is how we would think of that. That, we don't say that's in a quadrant. It's got a fancy name. It's called a quadrantal angle. So if an angle lies on the positive y-axis or on the negative or the negative y, or if it goes all the way around and lands back on the x, then we don't say that it's in a quadrant, it's quadrantal. Okay? Now, when we measure angles, there are two ways to measure angles. We can use degrees, which is something you should be familiar with, and we can use radians. Today we're going to focus on degrees, and the next class we're going to focus on radians. Okay, and most of you are familiar with if you go all the way around, that would be a 360 degree angle because it goes all the way around. This is a right angle, so that's 90 degrees. It's 1/4 of the way around. This is a 180 degree angle. It's also called a straight angle. And that's it. So again, it does have a vertex. It looks like a straight line, but there is a vertex right here. This is the initial side, and this is the terminal side. Okay. All right, on page 2, here at the top, we're going to draw some angles. So the directions say draw each angle, label the positive and negative rotation of each angle. So this is a 45 degree angle. So we're going to put our vertex, we're going to put our initial side. So that's where you're going to start with every single one. And then if this is a 90 degree angle, 45 would be halfway there. So that from here to here would be a 45 degree angle. Okay. Now, this exact same angle could also be measured going in the opposite direction. So that'd be a negative rotation. So if I started at this same spot and went this way, how would you measure that? Well, if it went all the way around, that'd be 360. But we're not quite all the way around. We're 45 degrees away from going all the way around. So if you take 360 and subtract that 45, then we have went 315 degrees in the negative direction. So this angle could be called a 45 degree angle. It could also be a negative 315 degree angle. Okay. The next one, negative 90. Okay. So negative means we're going to be going this way, and this would be negative 90. So from here to here, that is a negative 90 degree angle. But this exact same angle could have been measured in a positive direction. So what would that be? Well, again, if all the way around, so this would be, if we're going this direction, this would be 90, this would be 180, and this would be 270. So this is also a 270 degree angle. Okay, example C, 225. All right. So think about where that one's going to be. So 225 degrees. So this is 90. This is 180. So this is 180. And then this is 270. So we're going to 180, and then we're going to keep going. We need to go another 45 degrees. So 225 is 180 plus 45. So this would be 180. 45 would be here. So from here to here, that would be a 225 degree angle. Okay. This one, so if you go back to the first one, this one is in quadrant 1. This one is a quadrantal angle. It's not in a quadrant. This one is in quadrant 3. Okay. And then, oh, I didn't do the negative. So again, if I'm going this way, that exact same angle would be negative 90 plus another 45 degrees, so negative 135. Okay, so exact same way to name the same angle. Okay, and then 405. How would we do 405? So start here. Now, 405 is bigger than 360. So 405, we're going to go all the way around 360 degrees. Plus, we're going to do another, well, looks like we need another 45. So it's going to go all the way around and then another 45 degrees. So it's going to look like that. But if we draw this, it's going to go all the way around and then it's going to go up like that. So that would be a 405 degree angle. Okay. Now, if you measured this in a negative direction, the easiest would just be to start here, go around, stop there, and you'll get that negative 315 degrees, which is actually the same thing we had on the first angle. Now, if you take a look at these two angles, they should look identical. Okay, they both have the exact, they're in quadrant 1, they're at the exact same angle. It's just that this has an extra rotation to it. Okay, these two angles have a special name. They're called coterminal. Co means they share something, and what they share is a terminal side. So coterminal angles are angles that end in the exact same spot. And they're actually the exact same angle. It's just another way to name them. Okay? Adding or subtracting one complete revolution, which would be 360 degrees, will always give you a coterminal angle. So down here, the directions say finding coterminal angles. Identify all angles that are coterminal. All right? Well, if you want to say all, then here's how you would do it. A 150 degree angle, it would be 150 plus 360K, where that K just means all multiples. So all multiples of 360 added to 150 will give you a coterminal angle. But then the directions say find one positive and one negative angle. Okay, so if I take 150, add 360, looks like that would give me 510. So 510 is coterminal to 150. But if I take 150 and subtract 360, so grab your calculator. This one's a little trickier. 150 minus 360, you're going to get negative equals negative 210. Okay? So see if you can come up with all coterminal angles for the next two, and then one specific positive angle that's equal to that, and one specific negative angle that's equal to that. And this is what you should have came up with. So 30 degree angle, 30 plus 360K. If you add 360, you'll get 390, and if you subtract 360, you'll get negative 330. Same with the 225. So these are the answers you should have come up with. Now the next section says if each angle is in standard position, determine a coterminal angle that is between 0 and 360. So 765 degrees goes around and around and around. So what we want to do is we want to unwind all those extra revolutions until we get an answer that's between 0 and 360. So 0 and 3, so positive. So 765, we're going to subtract 360, and we're going to get 405. But that's still too big, so then we're going to take 405. We're going to subtract another 360, and we're going to get 45 degrees. So 45 degrees is a coterminal angle to 765. This is very important that you know how to take an angle that's like way, way, way too big and convert it into its coterminal angle that we can kind of deal with. Okay, if I give you a negative angle like negative 300, I don't want a negative angle. I want to add 360. So negative 300 and 360 would give you positive 60. So that is the angle that is coterminal to that angle. Okay, the directions also say to state the quadrant. Well, 45 degrees is in quadrant 1. I did not know that 765 degrees was in quadrant 1, but this one I can tell. Okay, same with 60. 60 is in quadrant 1. Negative 960. So take negative 960 in your calculator, add 360, and you're going to get negative 600. Add another 360. You're going to get negative 240. Add another 360. And finally you get 120 degrees, which that would be in quadrant 2. Alright, last part. You all know that when we're working a problem out, you don't always have, whole degrees. You don't always get answers like 46 degrees or 47 degrees. Sometimes you have decimals. So in other words, you can have parts of a degree. You can have 46.5 degrees. Well, there's another way to talk about those parts. And those are called minutes and seconds. And they're really exactly what they sound like. If you take a complete circle and chop it up into 360 pieces, each of those pieces is called a degree. Now, if you then take each of those degrees and chop those up even smaller into smaller increments, so take 1 degree and split it into 60 even slices, each of those slices is called a minute. Okay, so you could have like 45 degrees and 27 minutes. If you take each of those pieces and slice them up even further, so now we're going to take each minute and slice it up into 60 even pieces. Each of those is called a second. So you've got degrees, you've got minutes, and you've got seconds. Now, by the time we get to, we are talking about itty bitty little pieces. And when we're graphing something, there's no way that you're going to be able to like identify the seconds in a problem. Like, in fact, if you look at the first problem, there's really no way for us to look at this little bitty angle and tell, is this really 45 degrees, or is it maybe closer to 46 degrees or 44 degrees? Okay, so that's not what we're talking about. We're talking about huge circles. So like if you're dealing in science, if you're dealing with like a circle, like the Earth, okay, the Earth is a circle. So you can look at direction. What is the location of your house versus the location of the high school versus the location of someone else's house. Now you're talking about being able to use minutes and seconds to like really pinpoint your location. Or if you're looking at the solar system or something huge, that's what you're talking about when you're looking at minutes and seconds. So all we're going to do is we're going to talk about how to convert from one to the other. And the key is the fact that there's 60 seconds in a minute and there's 60 minutes in a degree. So if I had this number right here, this is 45 degrees, 10 minutes, and 15 seconds. So when I convert this into a decimal, my answer is going to be 45 point something. So I'm just converting the minutes and seconds into the decimal degree that would be equal to. Well, if you take the 15 seconds, so we're going to take 15 seconds and divide it by 60. Okay, so go over to your calculator, 15 divided by 60, and you're going to get 0.25. So what I've done is I've taken seconds and I've turned them into minutes. So now I don't have 45 degrees, 10 minutes, and 15 seconds anymore. I have 45 degrees, 10.25 minutes. That's what I have. Now we're going to take the minutes and we're going to convert those into degrees. So take the 10.25 minutes, divide that by 60. So 10.25 divided by 60, and you're going to get 0.1708. 33333. Okay, so we'll just stop right there. So now we've turned minutes into degrees. So we have our initial 45 degrees that we started with, 0.1708. So that is the decimal equivalent of 45 degrees, 10 minutes, and 15 seconds. Okay? To go the other direction, well, if we divided to turn the seconds into minutes and the minutes into degrees, then we're going to multiply to turn that decimal into the minutes and the seconds that we want. So 21.256 degrees, so a little bit bigger than 21 degrees. So let's just take the decimal part, 0.256, and we're going to multiply that by 60. And that's going to take this decimal, 0.256 times 60, and it's going to turn it into 15.36. So we've taken the degrees and we've turned them into minutes. So we have 15 whole minutes, and then we have this 0.36. We've got a little bit like a part of a minute. So what we want to do is we want to take that decimal, the 0.36, so this is minutes, and we're going to multiply that by 60. So 0.36, not the whole number, just the decimal part, 0.36 times 60. And that's going to be 21.6. And this would be seconds. Now, at this point, we can round. Okay, there isn't a smaller increment after seconds. Do not round this. Do not round this. Okay, these we're converting. But once we get here, we're kind of done converting. So our final answer, it's going to be the original 21 degrees we started with. It's going to be the 15, so 21 degrees. It's going to be the 15 whole minutes. And then it's going to be so this we can round up, 22 minutes. And that's how you would write 21.256 degrees as degrees, minutes, and seconds. Okay, so look at